Number 10. A patio is configured from a rectangle with two right triangles of equal size attached at the two ends. The length of the rectangle is 33 feet. The base of each right triangle is 3 feet less than its height. If the total area of the patio is 616 square feet, determine the base and height of the triangular portions. All right, so the first thing we can see here is that the length of the rectangle is 33 feet. So the rectangle, 33 feet. And then we can see that each right triangle, the base of each right triangle is 3 feet less than the height. So if we have the height being x for each of these, then the base is 3 feet less than that. So x minus 3, x minus 3. So the first thing you need to know here is that the area of a rectangle is length times width. The area of a triangle is base times height over 2. All right, so each of these triangles is going to have an area of base times height over 2. But since there are 2 of them, we're going to multiply that by 2, and the 2's will cancel. So that's going to be the area of the 2 triangles, and then the area of the rectangle will be 33 times x, length times width. And the total area of the patio is supposed to be 616 square feet. So x times x is x squared minus 3x plus 33x equals 616. We can see that this is a quadratic equation, so we're going to want to get everything on one side and set it all equal to 0. So x squared plus 30x minus 616 is equal to 0. So you can either use the quadratic formula, you can complete the square, or you can factor. This is factorable, but it might take you a while to find 2 numbers that multiply together to give you 616 and add up to 30. But if you can find those 2 numbers, then you can just factor it. Probably the quickest thing to do is to plug this into the quadratic formula, with A being 1, B being 30, B being 30, and C being negative 616. So let's use the quadratic formula. We have negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's negative 30 plus or minus the square root of 900 plus 4 times 616 is 2,464 all over 2. So that is going to be negative 30 plus or minus, if we add up 2,464 plus 900 and take the square root, that's going to be 58 all over 2. So negative 30 plus 58 is going to be 28 over 2, which would be 14. Negative 30 minus 58 is going to be a negative number, and we know that x cannot be negative because these are lengths. So we know that x has to be 14, and that is 14 feet. That's going to be the height of each triangle, 14 feet. And then the base of each triangle will be 3 less than that, so that will be 11 feet. Bob earns scores of 66, 84, and 72 on 3 chapter tests for a certain class. His homework average is 60, and his grade for a class project is 85. The grades are weighted as follows: tests 50%, homework 20%, project 10%, and final exam 20%. What must Bob make on the final exam to get at least a C in the class? Okay, so first of all, let's just remember what the percentages are. Tests, 50%. Homework, 20%. Project, 10%. Final, 20%. Okay, so his tests average, we don't know because we just have these individual tests. So the first thing we need to do is figure out his test average. And to do that, you have to add those three numbers and divide by 3. So 66 plus 84 plus 72 all over 3. You add that up. You add that up, you are going to get 222 over 3, which is equal to 74. So that's his test average. So his test average is, I'm just going to put this next to tests, 74. His homework average, they tell us, is 60. His project, he got an 85. And his final is what we don't know. So to figure out his grade, we just multiply the percentages times the average in each category. So his tests are worth 50%, so 0.5 times his average, his test average. And then 60 is his homework average, that's 20% of his grade. And then 10% of his grade is the project. And then the other 20% is the final, which we don't know. And he wants his grade to come out to be 70 or higher. So we're saying this has to be greater than or equal to 70. So half of 74 is going to be 37 plus 0.2 times 60 is going to be 12. And 0.1 times 85 is 8.5. And then plus 0.2x greater than or equal to 70. We are going to get 57.5. Subtract 57.5 on both sides, and we'll have 0.2x is greater than or equal to 12.5. Divide both sides by 0.2, and you are going to get x greater than or equal to 62.5. So he would need to get a 62.5 or greater on his final to get a C. Number 12, the height of a tomato plant H in inches is approximated by H equals 16 times T plus 4 to the 1/3 power, where T is the time in days after planting. About how tall will the plant be 4 days after planting? Okay, so 4 days, that's the time. So we're going to put that in for T. So we just write the equation, 16 H equals 16 times 4 plus 4 to the 1/3 power. 16 times 8 to the 1/3 is 16 times 2, which is 32. And since H is in inches, we have inches. So that's how tall it's going to be after 4 days. The next question is about how many days after planting will the plant reach 4 feet tall? 4 feet is 48 inches, so that is going to go into the spot for H. So we'll have 48 is equal to 16 times T, which is what we're looking for, the time, plus 4 to the 1/3. So 48 divided by 16 is 3. So we'll have 3 is equal to T plus 4 to the 1/3 power. Raise both sides to the 3rd power, and you have 3 to the 3rd is 27. That's going to be your T plus 4. And so subtract 4 on both sides, and 23 is T. So it's going to be 23 days for that plant to get that tall. All right, now we're going to solve these equations. So t squared minus 7t equals negative 10 is a quadratic equation. So we're going to add 10 to both sides, get everything on one side, and set it equal to 0. So t squared minus 7t plus 10 equals 0. This problem is very easy to factor. I would not put this into the quadratic formula when it's so easy to factor, because the quadratic formula has lots of pluses and minuses and all kinds of things in it that can cause you to make mistakes. If you can see that an equation is easy to factor, you should factor it. We know that 5 times 2 is 10, and it also adds up to 7. So make them both subtractions, so you'll get a negative 7 and a positive 10. If t minus 5 times t minus 2 is equal to 0, then either t minus 5 is 0 or t minus 2 is 0, which means that t would be 5 or t could be 2. So your two solutions for this problem are 2 and 5. That's your solution set. For number 14, you've got x minus 11 to the 2/3 power equals 9. So the first thing you want to do is raise both sides to the 3rd power. That's going to give you x minus 11 squared is equal to 9 to the 3rd power. So 9 to the 3rd is 81 times 9, which is 729. And now you're going to take the square root on both sides, which will give you x minus 11 equals plus or minus the square root of 729. The square root of 729 is 27. So x equals, if we add 11 to both sides, 11 plus or minus 27. 11 plus 27 is equal to 38. So that's one of our solutions. And 11 minus 27 is negative 16. So that would be our other solution. And on problems like these, it's very easy to check your answers real quick. So on number 13, if you put 5 in, you get 25 minus 35 equals negative 10. That's true. If you put in 2, you get 4 minus 14 equals negative 10. That's true. That took me less than 30 seconds. If I plug them in and they don't work, I know I made a mistake. I can go back and fix it. All right, same thing with the next one. 38, if I put that in, I'll have 38 minus 11 to the 2/3 power. So that's going to be 38 minus 11 is 27 to the 2/3 power. 27 cube root of 27 is 3. Squared is 9. That works. If I put in negative 16, negative 16 minus 11 is negative 27. The cube root of negative 27 is negative 3. Square it, you get 9. So they work. Quick and easy solution check will keep you in line and will keep you from making careless errors that you could go back and fix. Number 15, the first thing we can do is multiply this whole equation by 10. Just multiply both sides by 10, and that'll get rid of all these decimals. So 10 times 0.4 is just 4. And then 0.8 times 10 is 8. 0.1 times 10 is 1. 0.3 times 10 is 3. Now we just use the distributive property, and we will have 4w plus 4 plus 8 equals w plus 12 plus 3w, which will give us 4w plus 12 equals 4w plus 12, which is true. If we went ahead and subtracted 4w on both sides and 12 on both sides, we would get 0 equals 0, which is true, but it doesn't tell us what w is. So we would say that this is an identity. This equation is true no matter what you put in for w. And so we would say it's an identity. We would say that w can be any real number. On number 16, we do not need to multiply this out because we already have a perfect square equals some number, which means all we have to do is take the square root on both sides of the equation. Remember, whenever you take the square root, you have to put plus or minus. So plus or minus the square root of negative 5/9. T, if we add 1/3 to both sides, it's going to be 1/3 plus or minus the square root of negative 5/9. We can't work with the square root of a negative number, so we have to change it to an I. So T equals 1/3 plus or minus the square root of 5/9 I. Now we simplify it. T equals 1/3 plus or minus the square root of 5 over the square root of 9i. Remember, the square root of a quotient is equal to the quotient of the square roots. So that's 1/3 plus or minus the square root of 5/3 I. Square root of 9 is 3, so the denominator becomes 3. And this is how we would write the final answer, because it has the real part first and the imaginary part second. Okay, we have this equation with all these fractions, and so what we need to do is multiply both sides by the common denominator of the fractions, and we can see that we know that t squared minus 16 is a difference of squares. So if we were to rewrite this, we'd have t minus 2 over t minus 4. And I really highly recommend that if you have a problem with t's in it, that you don't write them like this, because a lot of you got confused and thought that those were t's. You thought they were plus signs, and that messed you up. Use some kind of interesting looking t so that it doesn't look like a plus sign. All right, this is equal to t minus 9. That's another way you could do your t, over t plus 4, t minus 4. Difference of squares, minus 1 over t plus 4. So this equation, the common denominator of these three fractions is going to be t plus 4, t minus 4. So we're going to multiply both sides by t plus 4, t minus 4. And now we can see that some of these things are going to cancel. So on the left side of the equation, the t minus 4 is going to cancel, and you'll be left with t minus 2 times t plus 4. T minus 9 over t plus 4, t minus 4, both of those factors are going to cancel, and we'll just have t minus 9. And then for the fraction, the second fraction on the right side, the t plus 4 is going to cancel, and we'll just be left with the t minus 4, which we need to put in parentheses so we can distribute this negative sign. So on the left side, we can multiply this out. T squared minus 2t plus 4t minus 8 equals t minus 9 minus t plus 4. Now we have t squared plus 2t minus 8 is equal to, the t's cancel, t minus t is 0, negative 9 plus 4 is negative 5. So if we bring this up over here, we've got t squared plus 2t, and then if we add 5 to both sides, we'll have minus 3 equals 0. Again, this is easily factorable. I would not use the quadratic formula here. T and t, 3 times 1 is going to give you 3, and you can make it equal 2 when you add up positive 3 and a negative 1. So this means that t would have to be negative 3 or t is 1, because that's what would make t plus 3 0 or t minus 1 0, and that's the only way you can multiply together to get 0 is if one of them is 0. So your solution set here is negative 3 and 1. Next one, we've got square root of d plus 7 equals 1 minus square root of d. When you do a problem like this, you have to isolate each square root one at a time. Let me just say that squaring both sides of this equation will not give you d plus 7 equals 1 minus d. No, you can't do that. Look, 2 plus 3 equals 5. If I square both sides of this equation, I'll get if I do it that way, the wrong way, I'll get 2 squared plus 3 squared equals 5 squared. That tells me that 4 plus 9 is 25, which is not true. Okay? You can't square each individual thing and get a true statement. That doesn't work. You can't do that. It is illegal. That is not good algebra. Doesn't actually work. Okay? So, let's do it the right way. First of all, you isolate one of the square roots. Well, guess what? One of them already is isolated. So you can just go ahead and square both sides. And the left side, when you square a square root, you just get whatever the argument is, the stuff in the square root. And then on the right side, you're going to need to multiply 1 minus the square root of d times 1 minus the square root of d. 1 minus the square root of d, quantity squared, is not 1 minus d. It's 1 minus the square root of d times 1 minus the square root of d. 1 times 1 is 1. Square root of d times 1, it's going to be minus the square root of d. Another one, minus the square root of d, and then plus the square root of d squared, which is just d. So d plus 7 equals 1 minus 2 square root of d plus d. The d's cancel on both sides of the equation. Now you are going to need to isolate the square root again. So if you subtract 1 on both sides here, you're going to get 6 equals negative 2 times the square root of d. Then you can divide both sides by negative 2, and you'll get negative 3 equals the square root of d. And if you square both sides, you'll get 9 is equal to d. And if you quickly go back and plug that in, which you have to do whenever you square both sides of an equation, you have to check your answer because it may not actually work. And if it doesn't work, you can either know that you made a mistake, or you can know that this is a solution that actually doesn't work in the original equation because we've added solutions when we square both sides that may not work in the original equation. So if we go back and check it, we put 9 in for d. We're going to get the square root of 9 plus 7 is equal to 1 minus the square root of 9. So square root of 16 equals 1 minus square root of 9 is 3. And that says that 4 is equal to 1 minus 3. That's not true. So this is not a solution. And so we would say empty set. This is how you write the empty set. You can either write it like that, or you can write it like that. Sorry, that doesn't look very good. Like this. Okay, here we have an absolute value equality, which is not dealt with in the same way as an absolute value inequality. All right, this is an equality. It's an equation. So the first thing we do is isolate the square root. We'll add 6 to both sides, and we will get 4 equals the absolute value of x minus 3. Okay, at this point, once we have isolated the absolute value, our algebra is over. We are not doing algebra now. What we're doing is using the definition of absolute value. Absolute value, the absolute value of x is equal to x if x is positive or 0, and it is equal to the opposite of x if x is negative. So what that tells me is, well, wait a second, I don't know if x minus 3 is negative or not. I don't know if it's negative or positive. Well, then either x minus 3 is equal to 4, or, on the other hand, it could be equal to negative 4, because 4 has an absolute value of 4, and negative 4 has an absolute value of 4. So it could be either one. Now I just solve. X equals 7, or x equals negative 1. I can go back and check and make sure this works. If you put 7 in for x here, you get the absolute value of 7 minus 3, which is the absolute value of 4, which is 4. If you put in negative 1 for x, negative 1 minus 3 is negative 4. The absolute value of negative 4 is 4. So these solutions are correct. I didn't make a mistake. The only way these wouldn't work would be if you made a mistake. Because in this kind of problem, the answer you get is the answer. But if you messed up, then it's not the answer. So you need to check your answers to be sure you did it correctly. Okay, solve by completing the square. To complete the square, first of all, we get everything in order on one side of the equation and set it equal to 0. Then we rewrite the equation, making sure that the coefficient of u squared is 1, and it is, so we don't need to divide the equation by anything. Now we're going to add something to make this a perfect square. We can also move the 82 to the other side of the equation, so negative 82, and we have to add the same thing to both sides of the equation. If you go back and watch the video about how to complete the square, you know that you're supposed to take the coefficient of your x term, or your, in this case, u term, take half of it and square it. Half of 18 is 9, square it, you get 81. So you add 81 to both sides of the equation. Now you can write the left side of the equation as a perfect square, and you know that that is going to be u plus half of the u coefficient, which is 9. And that's going to equal negative 1. Take the square root on both sides. U plus 9 is equal to plus or minus the square root of negative 1. So u plus 9 is equal to plus or minus I. The square root of negative 1 is I. Now we just subtract 9 on both sides, and we have u equals negative 9 plus or minus I. And that would be your final answer, because it is in the correct form.